Okay, now that we've looked at atoms and what makes them more stable once they get that octet and giving and losing electrons, we're going to talk about ionic bonding. Now, we're going to talk about it in terms of Coulomb's law. Basically, what it boils down to is opposite attracts and like charges repel. And so, like charges, the closer they get together, the stronger the force it is that pushes them away. And like charges, the closer they get together, the more they are attracted to each other. And so what happens is we have these opposite charges. And in an ionic bond, what you'll have is you'll have that positive charge from a cation and a negative charge from that anion. And what you're going to get is going to pull each other really, really close. And what this makes is it makes an ionic bond that's very, very strong. Okay, now what an ionic bond is: an ionic bond forms between metals and nonmetals. It's an extremely strong bond. Okay, that means it's going to have very high melting points. That means it's going to require very large amount of energies to break it up. So when we're looking at this, basically what happens is when we have this electron wants to give to the fluorine to make this have a complete outer shell, and fluorine, by taking it, will have a complete outer shell. And so therefore what we get is we get this really strong bond. Sodium will become positive and fluorine will become negative. And that positive and negative pull each other together. And they like to stay connected to each other. Okay, so let's look at an example. It says an ionic bond is stronger than other bonds, and explain using Coulomb's law why this is the case. So as that electron moves, this atom becomes positively charged and this atom becomes negatively charged. And as the distance between them decreases, what we'll see is the force of it increases. And what we'll see is the force in that Coulomb's law, opposite attracting positive and negative, that it keeps it bonded together and makes it very, very strong.